Hey there, kids. Time for another lesson. This is Module 2, Lesson 10. And the objective here, this is a whole new topic, with decimal multiplication. So it's actually kind of a fun change. It will challenge some of you, but check out these notes, and I think it's really going to be helpful. So our objective is to multiply decimal fractions. That's just a number with a decimal in it because it has a part of a number that is less than 1. And we're going to multiply these decimal fractions with tenths only, not multiple places to the right, just tenths, by multi-digit whole numbers, so several digits, using place value understanding to record the partial products. So with this lesson, we do have to use a couple of area models. It's only just, don't moan and groan. It's just a couple on the problem set and a couple on the homework. But the idea is to get away from the area model very quickly. So this Common Core way, I actually really like last year's video that I did for this, but I'm going to try to do it a little bit more completely and with you this year. So the idea here and the Common Core way, which kind of makes it a little extra complicated when it could be really simple, but this is the why behind the shortcut. So let's take something like 3 times 2 equals 6, and everybody should be writing these notes. You should definitely write all this stuff down. Very helpful. Let's take 3 times 2 equals 6. So if you did 3 times 2 and got your 6, and then multiplied by 10, you would get 60. But if you divide by 10, you would get 6 again. So let's call this a do and undo step. You can multiply by 10, but you can also divide by 10 to go back. So you go, and then you go back. So for example, 6 times 10 equals 60, but then 60 divided by 10 equals 6. So you're doing it, and then you're undoing it. Take this same concept and apply it with decimals. We're also going to be using unit form today to help you sort of take a second look at a decimal, but with a word. So we can take the decimal out and not have the decimal placement confuse you. So if you have 5 times 3 tenths, now it's like 5 ones times 3 tenths. That would give you 15 tenths, which looks like this in standard form. So this is the doing and the undoing. Let's say we have 5 times 3 tenths. But if I multiply this 3 times 10, I could get, instead of 3 tenths, I could get a whole number 3. But then really, if this is the other factor, I have to put the decimal back in. That's the undoing. So this is the do and this is the undo. So if I multiply by 5 times 3 tenths to get 15 tenths, here I can take out the decimal and then I can put the decimal back in. That's what this is. Now, that can be very confusing. So let's take a look at some other important aspects of today's lessons. So let's say you're decomposing a decimal. You can call it several different names. If I have 7 and 463 thousandths, I could take the 7 ones away and then I could lump or chunk these 463 thousandths. However, I could also change it in a different way. I could, instead of having the decimal breaking this 1 and the whole decimal fraction, I could break it right here and say 74 tenths, and then what's left is 63 thousandths. Or I could call this 746 hundredths and break it here, and then 3 thousandths that are left. So you can rename things in unit form. Now, this is also part of today's lesson, so again, more notes. If I have 2 factors here, then part of what we're going to do today is we're going to estimate so that we have something to compare to. So I take my factors, and let's say I round 43 down to 40, and I round 2 and 4 tenths. We're pretty much just going to drop off the tenths today. Okay, so if it was 2.9, I would drop it by going up to 3, but this one is 0.4, so we're going to go down to 2. So I'm looking for that approximately equal to, and whatever you can compare to. And the reason that this is important is because today when we're placing the decimal, I want to make sure that I put it in the right spot. So if I had 8.0, that would be wrong. Because if I have 40 twice, I should get 80. The decimal would be here. So the estimate is to help you place the decimal. Okay, now here is the area model that you'll be using a little bit today. Again, if I take the same 43 and the 20 plus 4/10, here's the renaming and taking the decimal out of it. This is going to be your best pal today, is using the unit form where the standard form number ends, multiply through without the decimal. Do not use the decimal anywhere in here. Think about the fact that if you're using your unit form, you're essentially multiplying by 10 to take the decimal out. So at the end, you would divide by 10 to put the decimal in. So you multiply to get the decimal out by 10, then you divide by 10 to put it back in. Use unit form here, call it uniform here, put the decimal back in. And then sometimes that can be really confusing. So I also have a little bit of a cheater help, which is what I used to use when I was growing up. And so math was never my favorite subject, and I couldn't explain why anything worked, but I knew that I had shortcuts for it. So the old way, and you guys are gonna love the old way because it totally works. Let's say I have 2 4/10 times 43. All you do when you multiply anything with decimals in your factors is you count up the total number of place value positions that are to the right of the decimal, and you put a matching amount in the answer. And that is all there is to it. So I could take all of lesson 10 and just say, oh, there's 1 here. Let's put 1 spot here. The decimal goes here. Okay, we could do that all day long. If this was 35/10, there'd be 1 spot here. I put 1 in the answer. Like, I'm not even kidding you. That is as simple as it gets. But they're going to want you to do it the new way, and so we have to show it the Common Core way because these math geniuses are really, really wanting you to understand everything about math, and so I'm trying to help you. So if we have 24/10, again, this is unit form, and then you can do the standard algorithm all the way through, label it in unit form, but the idea is I multiplied by 10 to get the decimal out. I'm going to divide by 10 to put the decimal back in. You get the same answer either way. Common Core, fancy, multiply, divide, or just count the spot. Still got the same answer. So anyway, those are your notes. I hope they are helpful, and let's jump into the book. So mine is on page 187, lesson 10. And we'll get started. Now we have to do several things on each of these first 2 problems. So first we're going to estimate. We also have to solve, but we have to use the area model. I'm so sorry. And we have to use the standard algorithm. That's over here. And you also need to make sure to express your products in standard form. You can't just leave it in unit form. Okay, so that's another check that you have to do. So if you take a look at what your factors are here, I have approximately, notice that means is approximately equal to. I have 22, which is pretty close to 20, and I have 2 4/10, which, like I said earlier, if it's a decimal fraction and it's pretty small, we can just drop that right off, drop off the decimal fraction portion. If I have 20 times 2, I would end up with about 40. Okay, now comes the area model. If I have 24/10 on top, I'm going to put 20 and 4/10 on the top. And my other factor will go on the side. And remember that we have to have the upward direction. So it's going to be 20, then 2. Because the 2 1s is what's going to multiply through first. So if I have 2 times 20, I get 40. And 2 times 4 is 8, but label it tenths. Okay, and then I have 20 times 20. That's 400. And 20 times 4 is 80, but it's tenths. Okay, so let's take this over here, and we're hoping that we'll get 48 tenths. And so sure enough, 2 times 4 is 8, and 2 times 2 is 4. Now, since they have already very kindly taken this 24 tenths and labeled it properly for you in unit form, it's like we don't have to worry about the decimal because they already did the times 10. They took it out, okay? So now that I'm finished multiplying by 2 1s, I'm going to hold this spot with a 0, and then 2 times 4 is 8, and 2 times 2 is 4. And so there's my second partial product. I can add these up. 8 plus 4 is 12. carry the 1, and I get 528. But is it 528? Is it all ones or what? This was ones, so it was tenths times ones, which makes tenths. Now, if this is 528 tenths, remember your place value positions. That's the objective of today, is to use place value to help you understand where to put the decimal. And so if I have 528 tenths, the last step is to express your product in standard form. It's going to be 52 and 8 tenths, and that's my standard form. Now, take this up and compare it. If I have a 2-digit answer for my approximate answer and a 2-digit whole number, 40 ones versus 52 ones, that's what you're comparing. If you didn't put the decimal in and you had 528, that's super far away from 40. So that's where the place value positioning is supposed to help you. Okay, now this is the 48 tenths. Again, we're trying to match our partial products, and that's where the area model is supposed to help you. 400 plus 80 would give you the 480. And again, we're looking at not putting the decimal into the partial products. We're just thinking about our unit form. Okay? So let's move on to the next one. So if I have 3 and 1/10, that's roughly 3. And 33 is about 30. And so 3 times 30 is about 90. So I'm looking for something in my product that's about 90. But this time I'm going to make an area model. So I'll have 3 ones, and then I have 1/10. And that's my top. And on this side, of course, bottom to top, 33. So that you can have the ones on the top where your first partial product would go here. So I have 3 times 3, which is 9. And that's like ones, just like we had up here. And then 3 times 1 is 3/10. And then 30 times 3 is 90. And then 30 times 1 is 30, but this is tenths. Okay, so let's do the standard algorithm. 3 times 1 is 3, and 3 times 3 is 9. And so I have 9 ones, 3 tenths. So I've got this 9 3. Okay, but we're not going to fiddle around with decimals in here. We just don't. Do not put any decimals in. Then this one's finished, so hold that spot with a 0, move over to this one, and again, they're giving us super easy numbers to multiply today. Yay! 3 times 1 is 3, 3 times 3 is 9. And again, I should get the same answer. So add down, don't put any decimals in, 3 plus 0, 3, 9, 10, 11, 12, carry the 1. And so do I have 1,023? Do I have 10 and 23 hundredths? Do I have 102? What am I supposed to be close to? I'm supposed to be close to about 90. So think about this. If I put the decimal here, that would give me tenths. It is tenths times ones, so tenths times ones makes tenths, which means my final standard form answer would be 102.3 or 102 and 3/10. Okay, and again, finish off that area model by showing that you have 90 ones and 30 tenths, just so you know. Okay, remember, if you're going to add those across as we go across, 30 tenths looks like this. Okay, so that's going to be 93 ones, but it's 930 tenths. 930 tenths. So it can be confusing if you have the decimals in here. That's why we don't put the decimals into the standard algorithm. Okay, now also thinking about the standard algorithm, if you were to put a decimal in here, it would be 1 here and then 1 in the answer. It would be 1 here and 1 in the answer. 1 here and 1 in the answer. That's the old way. And so that's always your safety mechanism. Fall back on that and just double check your counting. Okay, let's keep going. We get to drop the area model. Yay. We're going to estimate. That's our first step. Then we're going to use the standard algorithm. Yay. And express your products in standard form. Yay. So we drop off that area model here. So approximately 3. And then 47 is pretty close to 50. So we just want to go to a close 10. 3 times 5 is 15. And then there's that extra 0 because it's 50 times 3. So use the standard algorithm. We need to get something close to 150. Let's see how it works out. So 7 times 2 is 14. 7 times 3 is 21 plus 1 is 22. Hold this ones place with a 0 because now we're in tens. 4 times 2 is 8. 4 times 3 is 12. Nice and easy. Don't put any decimals in. 4 plus 0 is 4. 8 plus 2 is 10. 2, 4, 5. And then 1. So what is the label? It's tenths because it's tenths times ones. So how do I then write that in standard form? 150.4 because this has to end in the tenths place. Okay, next. Approximately 3. And then 94 is pretty close to 90. And so if I do 3 times 9, I get 27. And then don't forget the 0 because it's 90 times 3. Using the unit form here, let's do multiplication with our standard algorithm. 4 times 2 is 8. 4 times 3 is 12. Hold this ones place with a 0 because that's to represent the ones place because now I'm multiplying with 9 tens. 9 times 2 is 18. Carry the 1. 9 times 3 is 27. Plus 1 is 28. Add them up. 10, 8, 9, 10, and 3. So is it 3008? Well, it's 3008 tenths, which in standard form would look like 308 tenths. So that's your final answer for that one. I hope this is getting easier as you recognize the patterns. So we have 4 more with this method and not an area model, so yay. 6, approximately 6 ones. Some people might say, well, what about 5? Can I round it to 5? Well, I mean, you could, but why not just leave it at 6? And then this one, 44, could go to 40. Oh, I can tell my lead is going to poop out. 6 times 4 is 24, and the extra 0. And then we have the standard algorithm. Now, they haven't done it for you. I hope I have some lead in here. Good. They haven't set it up for you, so you can do it either way, but just remember to label it in unit form. 63 tenths times 44. And we're not multiplying the rounded answers. We're multiplying the actual. So 4 times 3 is 12. Carry the 1. 4 times 6, 24. Plus 1 is 25. Don't put any decimals in. Done here. Hold with a 0. 4 times 3 is 12. Carry the 1. I'll just use it again. 4 times 6, 24 plus 1 is 25. Again, I should get the same thing because I had 4 and 4. So 252 and then 252 plus the 0. Add them up. 2, 5 and 2 is 7, and then 7 again, and then a 2. I need something close to 240. So if this is tenths, then my standard form answer is 277.2. Okay? Don't forget to put it in standard form. All right, now this one, you probably, if I didn't tell you what to do, you'd get all kinds of different answers. Some people will put 14, some people will put 15. If you round it up, because 0.6, that would go to 15. 17, again, you want to be able to do this in your head. Bye-bye, lights. Hello, lights. You want to be able to do this in your head. I know 15 times 2 is 30. And then I have the extra 0 on the end. So I'm going to take my 3-digit number and I'm going to rename it with unit form. So 146. But what place value position is that in? It's in tenths. So call it tenths. Then actually multiply it by 17, but it's 17 ones, so leave that alone. Now let's start multiplying. 6 times 7, 42. 28 plus 4 is 32. And then 7 times 1 is 7 plus 3 is 10. Now we're done with the ones. Hold that spot. Go to the tens. And then it's 1. We love multiplying with 1 because it's going to be 146, right? So 1460 because 1 times 6, 6. 1 times 4, 4. 1 times 1, 1. And there was nothing to carry over. So add your partial products. 2, 8, 4, and 2. And then where do I put the decimal if this is tenths? I'm going to put it right here, 248.2. Okay, so there's your standard form answer. And again, 248 is pretty close to 300. Or think of it this way, 3-digit whole number, 3-digit whole number. The 0.2, that's just a little tiny decimal fraction. It's so small. All right, so let's round this one. I could leave it at 8, and then this would go to approximately 30. Some people round differently. Good luck with yours. 8 times 3 is 24, but we have 30 actually, so the 0 goes over. And then don't use the decimal, but rename this in unit form and put the actual factor below. 4 times 2 is 8. 4 times 8 is 32. Hold this spot with a 0 and then move over to the tens. 3 times 2 is 6. 3 times 8 is 24. Add them up. Add, add, add. And label. Tenths times ones is tenths. Now let's put it in standard form. It's got to be close to 240 or 3 digits for whole numbers. 278.8 would be your answer. Last one. Now, people will round this differently. Some people might go all the way up to 200. That's a pretty big leap. Plus, you have to think about what are the factors that you know in your head, because you really want to make this estimated product very easy on yourself. So if I know 150, or I know my 15s like I did up here, and I can round this up to 20, the zeros shouldn't concern you. It's just knowing those quick answers. So 15 times 2 is 30, but I have a 0 from the first factor and I have a 0 from the second factor. So my final product, when I place that decimal, it's going to have at least 3,000 or like 4 place value positions to the ones. So 1, 2, 3, 4. So let's put this down, 160.4 times 17, and start solving. Ooh, my bad. My bad. Whole point of the lesson, 160, and that's supposed to be tenths. Take the decimal out. Although if I continued with it, I would have just said, ooh, 1 place here, 1 place in the answer, just like I used to do all the time. Okay, multiplying with zeros is kind of fun because 4 times 7 is 28. So the 2 would go up and then the 8 would go down and then the 2 just falls down. And so basically 4 times 7 is 28. And I put it there because then it comes down. 7 times 6 is 42. Carry the 4. 7, 8, 9, 10, 11. And then love having the next one, a 1. Hold this spot with a 0, and you're multiplying with 10. I already did it, so it's each digit. 4061. It should be 1604 with a 0, 1604, and it is. Now we add these partial products. 86272, but label it. If it's all these digits that are then tenths, then the standard form answer would be 2726.8. And that's pretty close to 3,000. Look at that. 1, 2, 3, 4 places. 1, 2, 3, 4 places before you get to the decimal. And so that makes a lot of sense. So that's our double check. All right, let's do a word problem. Michelle multiplied 3 and 4 tenths times 52. She incorrectly, they're telling you, she incorrectly wrote 1,768 as her product. Use words, numbers, and or pictures to explain Michelle's mistake. So let's think about the estimation. If I have 3 times 50, okay, then I'm looking for approximately 150 as my answer. So first of all, this is like a red flag. It stands out because it's 4 digits. Okay, so maybe the 1768 are the right digits for the actual problem, but I have to put in the decimal. So let's do the work with our 34 tenths. We'll use our unit form just like we have been. Show the standard algorithm. 2 times 4, 8. 2 times 3 is 6. Hold the spot for the ones because we're done with that. We're moving on to tens. 5 times 4 is 20. 5 times 3 is 15. Plus 2, 17. Partial products. Add them up. We get the 1768, and here's where she left it. Bring down your label. Look at the label. Change to standard form by putting the decimal where it belongs. Okay? So if this is tenths, 1,768 tenths instead of ones, she wrote ones, you have to label it tenths. Then you have to actually put the decimal in to make the 8 in the tenths place, and that's how you can show that she placed it wrong. So this is 4 digits, and so it makes it a whole number, but it should be tenths. Okay, and so that's kind of part of the answer. This is part of the answer. This is the actual answer. So you just need to make sure to explain that. Also, click subscribe and come back again, because I am trying to make some nice, helpful videos for you. So be a subscriber and come back again. Anyway, last one. A wire is bent to form a square with a perimeter of 16 4/10 centimeters. How much wire would be needed to form 25 such squares? So if I take the perimeter of one square and I rename it 164 tenths, and I want to make 25 squares, then I can multiply this. I also need to think about the final answer being expressed in meters, because here I have centimeters. So let's go ahead and work it through. 5 times 4 is 20. 5 times 6 is 30 plus 2 is 32. And then 5 times 1 is 5 plus 3 is 8. Move over. Done with that one. Go to the tens place. 2 times 4 is 8. And again, really, it's 20 times 4. I keep saying that because I really want you guys to catch on. That's 8. Then 2 times 6 is 12. Carry the 1. And then 2 times 1 is 2 plus 1 is 3. So your partial products need to be added. Add 8, 9, 10, 11. And so you should end up with your 4,100 what's? Tenths. Okay, because it's tenths times ones makes tenths. So what actually is that? Well, in standard form, it's 410, like that. But what do I do with this? This is all the wire in centimeters. So I need to take my 410 centimeters, and I need to show it in meters. That's using our King Henry died unexpectedly drinking chocolate milk chart to think about where we are on there and how many place value positions they are apart. And so if you have the meters, okay, those are in the U for units. Okay, that's like the ones place. Or instead of putting 1, let's just put ones. Okay, those are all the same. Okay, unexpectedly drinking chocolate milk. Here's the chocolate. That's where the CM lives. And so you want to remember that it's going to be 2 place value positions. I'm going from a smaller unit to a larger unit, which means I have to divide, okay, by 2 place value positions, or 10 squared, in order to change this to a larger unit. So it's going to be a shift of 2 place value positions. The whole number will become smaller by 2. And so your final answer is going to be 4.1, or 4 and 10 hundredths, or 4 and 1/10 meters of wire. Okay, and I sure hope this was helpful. And come back again for another video. We'll see you on the next one. Bye now.